But now that we've got that yapping out the way, let's get to some more yapping. First, let's head over to Microsoft. I mean, it's best to get an example from the people who actually made the framework and the system that we're running on right now. That is if you're running on Windows and you're not using Mono. So let's go ahead and head over to MSDN, Async sockets, should be the first link, and there's their description of blah 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 blah. But let's go ahead and look at the actual code that they're doing here. First of all, they're important. They're networking libraries, net and sockets. Pretty important. You need those. And also the threading namespace for this little thing right here, and I'll get to that in a minute. But this first class that they have, state object. This is for holding the actual connected socket. It's holding the buffer size, even though this could be, it is a constant, but this could be outside of the class. But to each his own. And it's also holding the receive buffer, and it's also creating the buffer according to the buffer size that's right here. And this is for holding the string that's being transferred through the networking system. And I'll explain why this is here later on. We're not going to be using this in our application, but this is just the proof of concept. And then this is their asynchronous socket listener. This is their listener class. I'm sure you've seen a listener class in my other videos. This is just their example version of that. And the all done manual reset of it, they nicknamed thread signal, or they're saying is a thread signal. I'll get to that in a minute, so you can understand why this is here. But getting to the meat part of it, start listening. This is to actually start listening for a socket. It's creating a buffer stream, a buffer array, byte array. God, I need sleep. For of course holding or receiving the incoming data, which is pretty obvious right here. And for my previous videos, you guys should get that point by now as well. Now what this is doing is it's resolving the DNS of the hostname to get the IP addresses, so we can use that IP to bind it to that address, so the socket knows where to listen to connection, or where to listen for incoming connections. You can look at it like, I need an example here. It's like a station. It's a station, so trains know where to come in and trains know where to go out. Without a station, the trains have no idea where to go. But if you set up a station, you have your sign, and then trains know, oh, okay, I can go over there. Or a bus stop, the buses know, okay, that's where I can stop. So, it's something like that. So that's what this is doing. This is resolving the address of the host name. Our host name would actually be localhost, which would be 127.00.1, which is our host address, and that's where we're going to bind our listener to that IP address and to the port, so the connections know what computer they need to go to. Because, how can I explain this? It's like, basically, to simplify this, the IP address would be 127.00.1, which would be our local loopback address, and it's binding it to this port. So the applications and the sockets know to attempt to connect on this port. Because there could be so many programs, so many things running on the computer, so many networking applications, it needs to know exactly where to go. So the port is basically, you can look at it like the sign. It was, okay, so I'm at this address right here, the IP address could be the street. And you can say, okay, I'm on this street. Now, the port could be the address. The IP address could be the street block of all these different houses, and the different houses could be different applications. And the port is a specific address of that house, so the socket knows what door to go to knock on, see if your friend is there. Basically. And if your friend's not there, then the connection's going to reset or the friend's going to leave. So essentially, that's what this part is doing right here. That's what it's creating. And then we have the this line of code right here, which is creating a socket named listener. This is going to be the socket that's going to be the station. It's going to accept the trains, or it's going to accept the buses, or whatever. Whatever example is better for you. And then we're going to bind it to that address. So we're basically just sticking it in place and saying, okay, this is where we're setting up the station. Now, where were we? Yes. Back to this. So this will put the socket into a listener state. Because the socket, it can either connect or it can be used as a listener. In the server, we're going to use our main socket as a listener, which is why we're calling bind, and then we're calling listen. We wouldn't do this if we were just connecting a socket. We would just call connect instead. But this little setup here is what enables the socket to be able to listen for incoming connections, to set up our station to accept the cargo, which would be the sockets. Now, when I read Microsoft's example, I knew why they did this, but in our real world example, we wouldn't be doing it quite this way. This will be confusing for a beginner, I'll just say that. So now we're down to this thing that we were talking about before, the manual reset event. What this is telling it to do is it's basically telling it to wait. So whenever this is called, it's resetting the internal event to false, which is telling it wait and don't do anything. So it writes the console, we're waiting for a connection, and then we're calling begin accept, which will begin accepting connections in the background asynchronously. Pretty simple. And we'll get to the callback in 1 second here. But this little loop would confuse a beginner pretty hardcore and pretty heavily, especially if they try to do this in a real-world application. Now let's go through this and analyze what's going on here. Like I mentioned before, this is telling the manual reset event up here to reset to false. This has two states, as a matter of fact. Let me go ahead and pull this up. This is what I should have been doing. So, in this constructor, because you might have a use for this later on, or we might actually end up using it in this video. But so it's good that you just get well-rounded and know what these things do and what they are. So the technical term initializes a new instance of the manual reset event class with a Boolean value indicating whether to set the initial state to signaled. So setting the initial state to signaled means whenever wait 1 is called. This also has multiple parameters. If you wanted to only wait for a few seconds or a few minutes or an hour or however long you want the thing to wait before it just continues. Is once this line of code is executed, the thread stops. So it'll reset, la la la, right line, la la la, except wait 1, and then it stops. Until another thread, since this thread won't be able to do anything, calls set, which is a method here, set, which sets the initial state, well not the initial state, the current state, to true. And once that's set to true, this will be allowed to continue on and go execute the lines of code after that. So once it reloops, it's going to set this to false in case this was called, and it was set to true. Because if you don't recall reset at the beginning, then it's just going to think, oh, okay, keep going. And then it'll just keep looping on and on and on and on and on. But at the beginning of the loop, we set it, or reset it just in case. Just in case. It might already be false, but better safe than sorry. Resets it to false, begins accepting the connection, and then it waits until the connection is accepted. Now, let's go over to the accept callback so we can see why that's being done. At the beginning of the accept callback, it's setting all done to true. We'll just say it's setting it to true. So then it'll call begin accept again so it can accept a new connection. If this wasn't done with how this proof of concept was created, then it'll keep queuing begin accept back to back to back to back, and that would be pretty bad, and exceptions would be thrown. So that's why this is waiting here, and then it's signaling the main thread, since this will be running on another thread. It's going to tell the main thread, okay, keep going, and then it'll allow this allow this line to keep going, and then it'll execute the code, or the lines going down. In this case, it will loop back around to here, and then keep accepting the connection. Make sense? Okay. And now in our accept callback, this will be happening on another thread, just making sure you know that. Then it'll get the listener from the state, which was passed right here. The reason why the listener was passed as a state object is because the variable was created in another method. How we're going to do it in our real-world example, we're going to have the variable up top. There's going to be a global variable in our class, so we can access it anywhere without passing it. That's the reason why the listener was passed to the state object and then grabbed here. So we can call endAccept on that socket, so we can get the handle of the socket that was accepted. That is a mouthful. So let's go ahead and look at the endAccept method. Actually, why am I Googling it? I can show you guys this in a different way. Okay, so I was just playing around with the C# interactive shell, which is awesome, by the way, and 2015, it's cool. Even though I somehow managed to break it, it doesn't like console.readline. Don't do it. But let me show you exactly what's happening under the hood in .NET. So, let's just be quiet and go down to socket. Okay, and begin accept, begin accept, begin accept. But sometimes it's easier to see what it's actually doing than just going by blind faith and being like, okay, it just accepts. I'm not going to question how it happens, but okay. So this is the method that we're calling, begin accept. And just pass me a second. Yeah. So this is going to be the socket that's going to be used. This is the listener socket, basically. And then the receive size, which is what is the receive size for? Unless that's for initial data. That might be for initial data. And then we have our async callback, and then we have the object state, which would be passed to the callback once begin accept, well, calls back. Once it completes, I should say, and then calls the callback. But this is calling another method called doBeginAccept, which isn't actually, we're not allowed to access this method since this is called internally by .NET. But this is another thing. This is going down to the C functions. So we have the accept overlapped result, which is passing the current instance of the socket, the object state, which is here, and then the callback that's going to be called once it completes. Then we're calling, or then it's calling doBeginAccept, which is going to do the actual, or it's going to call the underlying C function. So this does the address buffer. Don't worry about this stuff. I'm just showing you what's happening under the hood. Where is the thing I'm trying to show you guys? No blocking. accept Q. And I just lost my train of thought. Where is the underlying function? X. Yeah, here it is. Okay. So this is going to be calling the underlying C function, which is accept X. And let me go ahead and pull this up. So you can understand the difference between multi-threading and the actual asynchronous socket operation. Don't worry about this too much, but this is calling accept X. This is what .NET is calling, and this little thing right here is our main concern. The overlapped structure right here. So in this little thing here, just to basically sum this up for you, this is happening down low level. And the system is handling what connection is coming in, which connection needs to be accepted, when are we going to tell whatever is calling it that a connection is accepted or a connection is ready to be accepted. This is what's happening down below. It's not just spinning off a thread and then calling a synchronous method and just waiting. There's more that's happening behind the scenes. Like I said, even I got a little sidetracked. It's been a while since I dove into that. But basically, that's what's happening. So in the past, when I would spin off another thread and then use a synchronous method inside of that thread, bad. That's bad. One, with a lot of connections, that's really going to hog up resources, and eventually that's just going to be ridiculous to maintain. So that's bad on me for teaching you guys that. But I just wanted to show you that's what we need to do so the system can handle all of that nitty-gritty crap, and then we only use multi-threading where we need it. Like if we were doing additional calculations, things like that. So now that we're going back through this example, now it's creating a state object and it's passing the socket that we accepted from inAccept. Now, this is another thing that would confuse some other people if you don't have the actual programming mindset yet. You're just trying to learn how slot A goes into slot B. This will be another confusing point. Now keep in mind, this is just a proof of concept. This wouldn't be how we would actually set up anything. This is just letting you know that, hey, this works, this is a way to do it, okay, now go now, shoo. But yeah, when it creates a state object, this is to keep everything together for the socket while it's receiving information. This is just to keep everything structured and together by passing the socket, which is going to be here, and it already has a buffer that it was created once we instantiate the class instance. Right here, that's already creating the buffer. And then when we call begin receive, this is when it starts receiving in the background. Now again, this is not just spinning off another thread and then just waiting for information to come in. Let's go ahead and look at this inside of .NET itself. Now, similar to before, it's creating the overlapped result and it's passing the socket, state, and the callback. And then it's calling do begin receive. We're just going to do something similar to what the accept method did. And begin accept also even will accept X mess with me even when I was coding in C++. So I apologize for that little mishap right there. And then we have now in begin receive. This is calling WinSock API receive. This is where it's calling the function or the C function under the hood. And now we have our overlap structure again. And it's basically the same thing as the other overlap structure. But again, the system is going to be the one handling the input, output, what connection's coming in, when it needs to be signaled that there's some information so we can transfer it and use it in our application. This is so we don't have to really worry about it too much. We let the system handle it. If the system is equipped enough to handle it, just go ahead and let the system do it. There's no point in reinventing the wheel. So that's what begin receive is doing. Now when the read callback is called, it will be on another thread. But it's not just sitting there waiting in that thread that you created. Okay? Making sense? I'm trying to break this down the best way I can. Now that we're in the read callback, again, this isn't the way we will be handling something, but this is just a proof of concept, so stay with me on this one. This is creating a string to hold the data that has been received. I think that's what would make sense. Yes, it is. Okay. And then we're getting the state object from the async state, which we passed right here. Okay? And since this is happening on another thread and we're not storing this anywhere else globally, this is the way we can keep track of it when the read callback is called. Because if we didn't do this and then the read callback was called, it was like, which socket called this? Which one? I don't know. Exception. So yeah, that's the point of that. And then we're just going to go ahead and grab the socket from the state object that called begin receive. Again, we called it up here. And then we pass the state over here. But we also set the handler, which is the accepted client, into the state object. So whenever the state object is pulled, we know which socket is the one who started the receive. And now it's reading how many bytes have been received within receive. Now I don't have to go into the actual .NET portion of it. It's basically the same thing as ind_accept. In the overlap structure, we already will pass the buffer for the or the pointer to the buffer, and a pointer is just a place in memory. Don't think into that too much. It's basically telling or putting or storing the place where that buffer is inside the overlap function, so it knows where to put the information that it received. And as a matter of fact, you know what? Let's just look at it really quick. So right here, the async result set unmanaged structure. It's setting the buffer, which is what we passed here, the offset, where we want it written, and then the size, what size we're expecting. This is what's setting this up, or setting up the overlap. So the system, again, can handle everything, and then once the data is received, it'll stick it in the buffer for us and then return it. So we can do stuff with it. That's what's happening in begin receive and in receive. That's what's happening in between those two calls. But again, another thread just not being shot off into memory. We're just going to call socket.receive and then sit there and wait for it to happen. So, store the data. We check and see if any data was actually read. If the data was read, then this is what that string builder was for up here. What we're doing is getting the string value from the byte array using the encoding class and using the ASCII encoding in order to get the string. Using the buffer size 0, meaning it's going to start reading the buffer from the beginning, and then the amount of bytes that were read. Now, the reason why it's doing the amount of bytes that were read is we might receive less than what we actually intended. So if we wanted to receive, let's say 100 bytes, for example, but something lingered, something delayed, something fell behind, and then we only received 50. If we tried to take those 50 bytes, write it to the buffer, but use 100 bytes in the size field, we would have a problem. And since data can get split up, and that happens quite frequently, we want to make sure we only read what we get, so we don't run into any issues. And then it's checking for the end of file tag, and we'll get to that once we get to the actual socket, I mean the client part of this. This is another thing that we're not going to do. We're going to do this a completely different way, but this is just one way you could do it. So what's being actually, let me just go over here really quick so you can see the context behind this. Don't worry about anything else. Don't worry about anything else. Okay, this is a test into file. This is what's being, not basically, this is what's being sent to the server. I could just went back. And then the server is going to keep receiving until it finds this. Now, what index of does is it will, this is for the string class, it will take whatever input you give it and see if it can find the index of where that is, basically. So if we had a string class, if we had a string class and we had this is a test, the index of this would be 0, 1, that's going to be kind of odd to look at, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it would be 10 and 11, which is kind of odd to look at it this way, but this is basically what index of does. If I called content.index of test, then the index of this would be, like the index of this would be 9. Index of either returns the index of it or -1 if it can't be found, which is what it's checking against here. If it's greater than -1, that means there was an index, that being 0, 0, 4, 7, whatever. If it's greater than -1, that means it was found. If it's not, then that means we haven't received all of the data yet, which you can see here. That means all the data was received, and then it'll write it to the console, and then it'll send it back to the client. If all the data was not received, however, then it'll call begin receive again, and then start the receiving loop back over. There are also a couple of other things that we need to take into account, depending on how we are actually going to pack the data. So doing it like this directly is not going to work out very well. But this is how they're interpreting this example. And with the Actually, no, let me go back up here. So it's calling begin receive again. It's going through the same exact process, and then it just keeps appending what it's receiving to that string builder until it finds in the file, and then it'll say, okay, everything's done. Let's send it back to the client, and then it will just actually. Does it actually close the connection? I don't think this example closes the connection. Does it? Okay, it does. It did this in an odd place. So now let's continue going down. With send, it accepts the socket and then the string of data that's being sent. In this case, it would be the socket that we accepted, and we're sending information back to the client. Here, it did what was done up here, but in reverse. Instead of getting a string, we're going to get a byte, so we can send it through the socket. Now this begin send is actually something, it's a little different. When you're receiving data, you should use begin receive, but when you're sending data, I'm not sure if they fixed it in the new .NET versions, but if you're sending data back to back to back to back, this will cause a serious memory leak in your application if you call begin send too many times in a row, without the garbage collector having time to gather itself. So if you're sending information, I would suggest using send instead of begin send. But if you're not sending information too quickly, then begin send is also fine. And so it's the same thing as begin receive, but instead of passing a state object, it's only passing the socket in this instance. You see how this would be kind of confusing if you didn't have someone sitting here explaining it to you? But in the send callback, which is basically the same stuff that we've been doing down there, unless you guys want to see it, you really don't have to. It's basically the same thing as receive in a sense. So like before, we're getting the state. And I also tend to repeat things because the more times you hear it, the more likely it's going to stick to your brain. So I usually say things 2, 3 times, 4 times. For it to get stuck, then just saying it once, then you have to end up rewinding and be like, wait, where was that part? I'm trying to get it into your head the first time. In send is called, like in receive or in accept, to get the amount of bytes that were sent. Now, usually, the bytes are usually all sent at one time. They're just received in pieces. They can be received in pieces. They're sent at once, but received in pieces if something gets chopped up or delayed along the way. This writes the amount of bytes that were sent to the console. Then it shuts down sending and receiving, and then it closes out and cleans up the socket itself. And we also have, there's also a try-catch statement in case something screws up, which you should do. And then we're down to the main method, which starts the listening process. Now let's do a quick run-through again and try and comprehend what Microsoft is doing here. This is a state object class that is holding the accepted socket. It holds the buffer size. It holds the buffer itself, and then the string builder for appending the received information. Then we have our manual reset event, all done, which is just basically our traffic light, I suppose you could say. What was this even for? This wasn't even used. I just realized that. Okay, that's... okay. It is what it is. It happens. We're people, we screw up. So now as a review, after that little rant of piece of code here that's not even being used, but we're getting our host information based on the host name of the computer to make sure we're binding to the right IP address, so our connections know where to go once they come through. We created our listener socket for accepting the connections. We bind our endpoint, we bind our socket to that endpoint so we can accept connection for setting up our station. We're calling listen with a 100% with a 100 queue backlog. These are the amount of connections that can be pending in a queue that are waiting to be connected. Any connections past 100 will instantly be dropped. The connections that are in that queue are just going to sit there and wait their turn to be connected. So if we have 100 connections, then we have 101 or 103. Those three are going to be knocked off until the queue opens up and some connections are accepted. Then we have our loop for accepting connections. We're setting all done to false, so we're not constantly calling begin accept until a new connection comes through. And then we'll call begin accept again since it'll be safe. We'll let all done know, hey, we got a connection. You can keep going. Keep on going and accept another connection. Or start accepting another connection, I should say. Then we have our socket listener that we're grabbing from the async state of the async result, which is passed right here. Then we create our state object, which will hold the accepted client, accepted client, accepted socket, and then we'll call begin receive, and we'll pass the buffer size, the buffer, the index we wanted to write at the beginning of the buffer, so we're putting 0. The buffer size, this is just the normal socket state, you don't have to worry about that. We're passing our callback, and then the state object itself. Now in our read callback, we're creating a string to hold the content after we're done with our string builder. Then we'll grab the state object from the async result, which was passed right here. And you know about all the stuff that's happening in between the begin and end receive, or begin and end accept, begin and end receive, begin and end send, and so forth and so forth. I lost my train of thought for a second. And now here we're getting the accepted client. We are getting the amount of bytes that have been received. We don't have to do anything, we don't have to do anything with the buffer here because that was already done under the hood. We're just getting how many bytes we actually received. That's all we need, since the data is already going to be in the buffer if we received any. And then we'll append what we received, if we received any, into the string builder, and then we'll set content to the string builder toString, which just returns the string builder as a normal string, or returns a string from the string builder. I know, some things are confusing. Then we check the content to see if it has an index. If it has in the file, if there's any index of in the file anywhere in the content, then we know, okay, we received everything, nothing was split up. And then we'll send it back to the client and then shut it down, since that's being done in send as well. Which would be another thing that would confuse someone if they were trying to build some sort of actual application. But if we didn't receive anything, or we didn't receive all of the data, Then we're going to call begin receive again, and continue the read loop over and over again until we find in the file. But if we did find in the file, we'll convert the string back into bytes, and then we'll call begin send, and we'll pass the bytes. We want to send from the beginning of the buffer, so we're using 0, the full length of the buffer, since we want to send everything. 0, those are socket states. Those are socket states, if I remember correctly. You don't have to worry about those. Then we're using the async callback and passing the socket itself. And in the callback, I'm going to wrap it in the try catch just in case something messes up. We'll grab the socket from the async result. We'll read the amount of data that we actually sent. We'll display the amount of data that we sent. We'll shut down sending and receiving privileges, and then we'll shut down the socket itself. Or we'll write an exception to the console just in case something messes up. And then in our main entry point, we'll call start listening. That wasn't even that much. It's just, it would be odd if you were reading this and trying to comprehend, if you don't have the programmer mindset yet of how to change this into an actual application. And I'll just give you a brief summary of what you could do with this. So I'm not going to do this perfectly. I'm just going to do some pseudocode really quickly, just to give you a quick idea of how I would envision this. Actually, no. I'll do this after. I'll do this after the fact.